This is how the questions in Trig always starts. It starts with a question where you need to evaluate. Now, the evaluate questions, we either give you a ratio, and we say the sine of theta is p over k, find the cos of 2 theta in terms of p and k, that type of thing. Or we give you some number, some other number there, so that you need to draw a triangle. And then we restrict it by another ratio. Or we give you the coordinates of a point, either in the quadrant, or we give just the coordinates and we restrict it. So this question is always going to be there. You must be able to do this type of question tomorrow. So let's have a look. In the diagram, P is the point K1. That's that point over here. Is a point in the second quadrant. Okay, they've given us the quadrant. So we know that K is positive. K is an X value. So we know that K is negative. Okay, and the Y value is already positive. So we know that whatever we're going to get as K, we're going to pick the negative option. Okay, so this is a point in the second quadrant and root 5 units from the origin. So they've given us that distance over there. R is a point on the positive x-axis. So what do we know? We know x is positive and we know the y value is 0 at that point. Then they give us obtuse angle ROP as theta, that big one. Okay, so folks, we always start this question by solving that triangle over there. Okay, we need to, that's the first thing we do. Okay, so in that triangle, why do we do it? Because they're most probably going to ask me questions where I need the opposite and the adjacents. Okay, and where I need to find k. So let's have a look if we can do this. This is 1. Look at that. Then this will be the root of 5 squared. So O, I'm going to call this just 0.0x. So that's the first thing I'm going to do. What is OX? OX is the square root of the hypotenuse squared, which is root 5 squared minus 1. So this is the root of 4, which is indeed 2. So the length of OX is 2, but because it's on the negative side, we have a minus 2. And look at that, folks, we have the value of k. K is negative 2 if we need it later on. What else can I get from this diagram? I think that's about it. Okay, let's have a look. The questions I asked, the first one, find the value of k, and we just found the value of k. So we can label this as the first question. So what is k? K from there will be negative 2, using Pythagoras. That was just for a measly little 2 marks. Okay, so your distance is positive. Remember to change the sign to accommodate the position of the point. Okay, let's read on. Without a calculator, calculate the value of tan theta. Now that's exactly the point I made, folks, is we need the other sides. So without a calculator for 1 mark, the tan of theta is opposite 1 over adjacent minus 2. So the tan of theta is indeed minus a half. 1 mark, we've got 3 marks so far. Now they want the cosine of theta, 180 plus theta. So we know that the cosine of 180 plus theta lies where? It lies in the third quadrant, this quadrant here, where cosine is negative. So it's minus the cosine of theta. And the cosine of theta is adjacent over hypotenuse, which in this case, the double negative will make 2 divided by the root of 5. Let's read on. So far, I think we've got full marks for this opening question. This looks like the first challenging one in this opening set. They asked us the sine of, what's it, theta plus 60. And there's all of a sudden, there's A's and B's all over the show. So let's have a look. Write the sine of theta plus 60 in the form, degrees in the form. Now I'm going to put the form in another color. The form is something plus something divided by the root of 20. Now, folks, we've got to be careful here. We've got theta plus 60, and we're adding things together. Now, that must tell you something. That should shout out to you, I'm a compound angle. Make me and expand me into the compound angle expansion. Well, let's see. We've got theta in the diagram. I don't think we're going to lose. So this becomes, I'm going to try and squeeze it in here for us, is the sine of theta, the cosine of 60, plus the cosine of theta multiplied by the sine of 60. It's my compound angle law. Now the sine of theta is opposite over hypotenuse, so 1 over root 5. I was wondering, where does this root 20 come from? The cosine of 60 is, as usual, a half, plus the cos of theta is minus 2 over root 5, and we have the sine of 60 as root 3 over 2. Okay, now let's see. What must we now do to get it into this form? I'm just going to make space here. We have 1. The LCD, in fact, is 2 root 5. So this is 1 minus 2 root 3. We still don't have a root of 20 in here. At the denominator, we've got 2 root 5. Now, please, folks, don't think that you've got to multiply with the conjugate pair. In other words, with 1 plus 2 root 3 over 1 plus 2 root 3. There's no plus in the denominator. So just look a little bit deeper. Spend more time on 2 root 5. Look at what's going to happen here. This is the equivalent of 1 minus 2 root 3 over the root. If I now take this back into that, it's 4 multiplied by 5. Okay, I squared it and I put it back underneath the square root so that it returns to its original position or original value of 4 before it left the square root. So here I have 1 minus 2 root 3 divided by the root of 20, and indeed it is in that form that they asked us to put it in. The question I'm going to look at now is asking us over here to prove the identity. So I'm going to look at this one, and then we're going to look at this beautiful sigma one. This is a very interesting question. I love it. And it's for 5 marks. So let's start. Again, it's an identity. So we're going to start with the left-hand side. Our left-hand side has more information. The right-hand side does have a double angle, but yeah, the most I can do with that right-hand side is sine 2x over cos 2x. And then I don't want to be in a position where I make the decision to decide what I'm going to do with cos 2x in the denominator. So let's start with the left-hand side. A little bit of algebra here shows us beautifully that that's an LCD of the product of this denominator and that denominator. So that gives me a minus b, a plus b. And algebra tells me it's a squared minus b squared. Got my first mark on the board. Now here, clearly, I've got to square that top because this denominator multiplies with cosine x plus sine x to form that squared. Minus and the same for cos x minus sine x. All squared. Now, folks, I can simplify it by factoring it again into a minus b, a plus b, and see what cancels out. Or I can do my squaring of both those binomials, and let's see which one gets us there. I would like to do something interesting and factorize. So I get cos x plus sin x minus this, which gives me minus cos x plus the sin x. Remember the double negative there. Okay, so that's a minus b. If this is a, I'm doing a bit of algebra. I'm going to a squared, b squared. So a minus b. And the second bracket, excuse me, will be a plus b. So cos x plus sin x minus that cos x that was there. Remember, there's just a positive, so it remains a negative. And then here, remember, now I have a minus b, a plus b. So this stays as a plus, sorry, it's a plus cos minus a sin x. Okay, now all of this goes over, where's my denominator? Cos squared minus sin squared, which is the cos of 2x, my double angle formula. Now let's see what happens to the top. I might have been too clever for myself here. Let's see what we have. We have cos minus cos, which is nothing. So I have twice sine plus sine is 2 sin x. Okay, and here I have cos and cos, so I have 2 cos x. Okay, that looks fine. The sine and the minus sign removed themselves from the equation, becoming 0. Divided by cos 2x. If I remove a 2 here, let's remove that 2 over there and put it in front. Then I have 2 sin x cos x over the cos of 2x. Now, folks, I'm trying to write as quick as I can. My handwriting is looking terrible here. Let me just change that so that it looks like a cosine of x. Now we know the top becomes the sine of 2x. The denominator becomes, or is still, the cos of 2x. And voila, this is twice the tan of 2x, which is indeed our right-hand side. Okay, it worked out quite nicely, that one. Took a little bit of a turn there, another turn, and we got to exactly where we had to go. As I said, you could also have squared those two brackets. Now, the last question in this particular section of work is asking us to find the sum when A starts at 38 degrees and finishes at 52 degrees of cosine squared A. Now, when I saw this question the first time, I thought, wow, this is going to be a little bit tricky. We'll have to change those angles. We have to see if there's angles that together gives us something. And then it struck me, hang on, I know what? I know the following. I know the sine squared of an angle plus the cos squared of that very same angle is going to be 1. That's the first thing that came to mind. The second thing that came to mind is complementary ratios. I know that the sine of 20 degrees is, for instance, equal to the cosine of 70. The ratios are complementary, the angles are complementary, so I could possibly work with those two. Now remember, I've got 14 terms here. How do I find out how many terms I've got? I actually have 15. It's the top minus the bottom plus 1. So this sequence starts as the cosine squared of 38. Then we have the cosine squared of 39. And then we have the cosine squared of 40. And it continues to the last 3. Let me put the last 3 in here as cosine squared 52, okay, plus the previous one would have been cosine squared 51, and the one before that would have been cosine squared 50. So what do I have? I have a middle term, because the big thing here is my number of terms. So my number of terms in this particular sequence is 52 minus 38 plus then 1. Now, folks, if you calculate that, it gives you a result of 15. Now, look at the magic. Now we're going to perform the mathemagics. Have a look at this. I'm looking for complementary ratios and complementary angles. There's one. The first and the last together gives me 90. So I know that this can be written as, I'm going to do the changes up here in the bottom, just in a bracket. I'm going to write that as cos squared 38 degrees. And this I'm going to change to plus the sine squared of 38 degrees. Now, why is that the case? Because 52 and 38 gives me 90, which is complementary. So every second middle two, the next two, the next two, I'm going to change to complements of one another using my complementary angles. Okay, so how many times is that going to happen? How many pairs can I form of 15? Of 15, I can form 7 pairs. And my middlemost number will be my next number, which is in 15, if I divide 16, it's the same as finding the median value here. Okay, it's an odd number. You add, the 8th one is the median. You add 1 and you half, and you have your median value. So the middle term, if I finally work with this idea, combining those two, combining them, keep on combining until I get to the middle term. Now the middle term will be the 8th term away from 52. So there will be 7 pairs of 1, plus then the cosine of the middlemost term, which is the term that lies directly in between these two terms over there, which is 8 away from 38. Okay, so I can say it's 38 plus 8 to give me the cosine of what is 38 plus 8. If there's 15, if I add 7, I'm at 45. I am at the cosine, let me just erase here. I'm going to take my 38 degrees and I'm going to add to the 38 and I get the cosine of 45. Where's this now? 45 over there, and that gives me 7 plus 1 over the root of 2 as my sum of my sequence. The big thing here with the last two questions was knowing where to start with the identity, number 1, and number 2, knowing that I have to change these into their complementary ratios until I get to the middle one.